Hello again. Let's get started. Let's look at this example right here where my cursor is. D by dx of e to the power of the square root of x. Now we're going to let u equal the square root of x. So we have d by du of e to the u times d by dx of the square root of x, which is naturally my u term. Now d by du of e to the u is naturally e to the u. And then now d by dx of square root of x, remember from times past, that's 1 over 2 radical x. Radical meaning the square root. And so that's equal to, now e to the u, I'm going to replace u with radical x, and that goes on top. And then the 2 radical x just stays on the bottom. And then, so that equals, now we want to rationalize the denominator, so guys, again, remember, you stick a radical x down here, another radical x down here with the one that's already here, and you're going to have to stick one up here as well. So you get radical x times e to the radical x over, now technically, this would be 2 times radical x, but the two square root of x's would just make ordinary x down here. That was the whole point, was to get the radicals out of that denominator already. Okay, so there's that, and we're done. So that'll be all for that example. Just yet another chain rule example. You can use a chain rule with all sorts of functions, all sorts. But anyway, moving along, and my clicker is misbehaving. What else is new? Sorry. Well, now it's getting on my nerves. Sorry, guys. So we have, now let's look at this, d by dx of, now here, yeah, we could probably do the chain rule, but here it's a much better idea to do low d high. This lends itself to the low d high rule, the division rule, when you're dividing one function by another and you're doing the derivative of that quotient. So remember, low d high minus high d low over low squared. So low is x plus 2, high is x plus 1. So low x plus 2 times d high, that's the derivative of x plus 1 with respect to x, minus high, which is x plus 1, d low, which is the derivative of x plus 2, all over the square of low, which is parentheses x plus 2 squared. Low d high minus high d low over low squared. Remember that. We've talked about that in times past, but just remember that's how it goes. Or if we've not talked about that, we should have. I'm pretty sure we have. Low d high minus high d low over low squared. And then now, guys, the derivative of x plus 1 is just 1, because this one gets killed, and this x right here turns into 1 when you derivate it and do the derivative. So, but now x plus 2 times 1 is just x plus 2 itself, so we can drop the parentheses. 1 is understood. Now here we got that minus sign. Now, again, this is 1 as well, because, guys, this 2 gets killed, this x turns into 1, so x plus 1 times 1 is just x plus 1 itself. Now, you got to keep the parentheses because you're minusing the whole entity x plus 1. You know that if you can go ahead and drop the parentheses, but you got to do it with care, because you would get, if you drop the parentheses, which is what I do on the next step, you get a minus x and a minus 1. You got to do that. Minus sign distributes through both terms. Just be careful about that. So now this x and this minus x are going to kill each other off. The 2 and the negative 1 make a positive 1 up here. So you just get 1 over the same old denominator, the square of x plus 2. That's it. That's our derivative. Notice we did not do the chain rule this time. We did the low d high rule. This is called the quotient rule. That's the fancy smancy term for it. But anyway, the quotient rule, and we use the quotient rule again, or the low d high rule. So I do low d high minus high d low over the square of low. So 5 plus 2 is low, 3x minus 1 is high. So low times the derivative of high with respect to x, but minus high d low with respect to x over low squared. So now 5x plus 2, now the derivative of 3x minus 1, this minus 1 gets killed, and the derivative of 3x is just 3 itself. So there's that. And that 3 is going to distribute across 5x plus 2. And then now this minus sign comes next. Okay, then our next step, the 3x minus 1. Now the derivative of 5x plus 2 is just 5, because the plus 2 gets killed, and the 5x, when you derivate, you get 5. So there's that. and then over low squared. So now distribute this 3 across 5x plus 2, you get 15x plus 6. Distribute this 5 across 3x minus 1. Now be careful, you're really distributing the minus sign and this 5. So negative, you're really distributing negative 5, so you get negative 15x plus 5, because guys, yeah, this would have been minus 5, but this minus sign hits this minus sign right here. This minus sign hits this minus sign, and you get this plus sign right here, okay? Watch out for your minus and plus signs. Be very careful. Well, 15x minus 15x is gone, and then 6 plus 5 is 11, so you just get 11 over the square of x plus 2, and that's it. Again, we just did the Lodi high rule, and I'll leave it for you to do this guy right here and this guy right here.